I was looking at my analytics, and I'm about 1/10 of the way till I can start monetizing this. So, you know, look out for ads soon. So what we're gonna do first is we're gonna open Rhino, and if you go to the Dropbox folder, I'll give you all a second to open this. Under class files, there's a GIS and site model editing folder. That's today. Also worth quickly mentioning, I've renamed the videos so that they have the dates corresponding to the class, so that if you want to know what you should actively be working on, just look at the date on the video, and that'll sort of give you an idea of where it falls in the course. So 2002-10 GIS and site modeling, and essentially what we're going to do is we're just going to open the site model file. There we are. And what you'll find in this site file is sort of a, I guess, a small section of the larger site model that I'm sort of working through as you guys are working through this. And this is just to demonstrate some of the techniques that you're going to use to kind of clean up this site model. So essentially in here, you can see that this is an edge of a drape. So that's perhaps where you've dragged a rectangle over your mesh and it's sort of fallen off the edge like so. We have our rebuilt BREP houses right here. We have this silo right here, and we have our Meerkat imported data on the bottom here. If you look on the okay. So essentially, what I'm missing here, and I guess it's because I saved on my computer, is, or on my home computer, is we should have an image file underneath our
so in
Rhino
this
file
video,
there, but that's okay. We can overcome and adapt and sort of just grab something from Google Earth to sort of, you know, make that work. So I'll quickly show you how to get something from Google 2D. I do this for the Mac portion of the video, and I'll save this in the Dropbox as well. So I don't know the exact URL, but if you just look up Google Map 2D, you'll see there's other versions of Google Maps on the web, and then you can open Maps in 2D mode. And essentially all this is going to do is it's going to get rid of that 3D mode, so that kind of tilted faux 3D mode that Google Maps presents in by default, and it'll just bring up the old satellite view. Now this data I think is still from 2020, so it still should be up to date. It's just an orthographic projection. And what I'm going to do here is I'm just going to zoom in, and I am going to print screen. So in this case, it is on this computer function print screen, like so. I'm just going to open Photoshop. Then I'm just going to copy this into my Rhino file. So you'll find that building a site model, a lot of the times you are gonna be doing this kind of method where you kind of trace over things, and that's just sort of how it goes. So let's see, function print screen. Actually, I think it's just print screen. There we are. And then I'll just create a new thing. And I'm just going to paste my view in here. And what I'm going to do is I'm just going to crop this quickly. If you go through the video, it's going to show a more accurate way of placing an image, and it's a little bit more automatic. So again, I encourage you to watch the video, but this is sort of a quick way to overlay an image on your Rhino file. So I'm just going to crop that, and again, I'll save this in the Dropbox file so we all have the same thing. And I'm just going to save it in my Dropbox file. So class files, GIS, and I will just save it as a JPEG called site ortho. Okay. Now, what I'm going to do now is I am just going to go into Rhino, and I'm going to use a command that's extremely helpful. So I use this a lot for working from my boss. She does beautiful hand drawings, but then it's like, okay, convert this into the computer. So I actually end up doing quite a bit of tracing. So what I do is I just go into my top view. I make sure project is on, so that's going to make sure that your picture frame is projected onto the C-plane, so the main XY grid. And then I will just type picture. I believe in Rhino 5, if you're using Rhino 5, it's picture frame. And then essentially just navigate to that site ortho image and then drag it out. If you need to scale an image, you can hold Shift and you can stretch it or whatnot, but in this case, we just want to drag it out. Now again, like I said, if you watch the video, it's going to show you a method that makes sure that this image is placed exactly where it should be and it's to the right scale kind of automatically. But for our case here, what I'm going to do is I'm just going to take some of our lines and sort of try to line them up. So for example, I see the railroads are right there, and this thing is right here, and then I'll try to scale this up. And I'll save this file as well, because just so everyone sort of has the same thing. So this is, let's say, approximately correct-ish, because this thing's actually right. I'm gonna kind of fudge it. So again, this is why Meerkat's very useful, so you don't have to do this. Okay, we're gonna say that's about right. It doesn't really matter for this because the method will be the same. So let's imagine that this is perfectly scaled. Again, Meerkat will allow you to scale this perfectly. And what we'll see is we'll have this image underneath. One of the things you can do with images that you want to trace from is you can always select them. Oh, and I'll save this file right now, just so we have everything in it. Site model, I'll save it as ortho. One thing you can do with these images is you can always go to their materials property palette. So it's in the right side palette. If you don't see a little paint tube, then you can always click the little gear to open materials. And if you click on the little paint tube, what you can always do is you can always increase the object transparency. And that's just going to make it so it's not so visually, I guess, bold. And of course, this might be the wrong image here. Yeah, okay, it's this one here. And you can see that increases the image. So I just selected the old ortho image file. So you can increase the transparency like so, and that makes it just a little bit less visually obtrusive. Once you've done that, you can select this reference object, and you can just go Control L, and that's going to lock in. That way you just can't select it. So it's just kind of a nice underlay underneath your model. And I'm going to go back to shaded view. The other thing you can do in Rhino, which I've done in this file, just so I can kind of stay on track, is you can click the little cog and you can open a panel called Notes. And this is, you know, kind of a niche thing, but I do find it useful for sort of keeping notes with a project. And I'm going to use this in this case just to, like I said, stay on track. So the first thing I want to show you how to do is kind of how to define roads a little bit better. So in Meerkat, if you haven't gone through the video, essentially what you're going to see is that roads are going to show up as just simple lines like so. Now, this is very good for a large citywide site model because you don't want to give these roads thickness, or if you do, you'll do so in something like Illustrator or whatnot. But for a finer grained site model like so, you kind of want to add some thickness to these roads. So that being said, and this is why I said that Meerkat in importing GIS data from the city of Vancouver is maybe, you know, not 100% necessary for this site model in particular. But what we're actually going to do is we're going to trace the ortho image. Now, for an actual professional, like, you know, this needs to be submitted to the city for in a construction document, you're going to say, hey, I need survey data, right? So you can't work from this way, but even for like a competition, design development, this kind of tracing the ortho image when it is lined up properly is a very good approximation. I think the ortho image, it's like max jitter is like 0.5 meter. So on a scale like this, that's really quite accurate. So what we're going to do is we're just going to make a new layer, and we will just call this layer, I always have like a working layer. And essentially my working layer is things like lines that I'm going to use to slice a surface, or sort of grasshopper references, yada, yada. So we'll just make a working layer. I'll choose this sort of bright pink so I can see what's going on. And essentially for a road, what you're going to do is you're simply going to trace it. So I'm going to probably just use the control point curve. And I am simply going to trace the road like so. And I'm going to drag it over the extents of the surface. So the surface defined by these boulder lines right there. And that's because we're going to slice this surface. And you can grab the line. So if you select the line, you can also adjust it by the control points afterwards. The other thing you can sort of do is sometimes just reference the image. So in this case, I mean, like, there's a car there, so I have a feeling that the first time I drew my curve, you know, is a little bit too low. The other thing I'm going to do now is I'm just going to offset this. So I'm typing in offset into Rhino, and my distance, I'm going to just sort of drag out like this, go to the other side of the road. And then what I like doing is I kind of assume that usually, like, people build roads, like no one makes a road that's like 9.4154 meters wide. So if I see something like that, I'll just round it to the nearest kind of, I'll call it major floating point. So in this case, 9.5. And then now we have our road here. What I'll do now is I will take my surface, I'll click split, or you can type split, and I'll select my two slicing lines, and I'll just click enter. So you can see that now, if I go in my perspective view, I have two surfaces. So I have sort of these two adjacent surfaces, and I also have this one little middle road surface. What I like doing for these kind of models is for any kind of road that's next to a curb, you're going to assume that there's like a sidewalk curb, right? Barring any driveways, which I don't know if you want to model in, be my guest. But for this case, I'm just going to drop this road. In most curbs, I think they're actually 7 centimeters. So I'm just going to select this surface, click the little blue arrow, and remember we're working in meters, so I'm going to type negative 0.07. It's going to drop it down the required amount, and that's going to be our road there. The final thing we're going to do is we're going to fill this gap So you can see we have these little edge gaps here. And we're just going to extrude two surfaces using these surface edges up 7 centimeters, and then that way we'll have our complete road. So what I'll do is I'll go to Surface, Extrude Curve, Straight. I'll select these two edges. I'll hit Enter. You can see that it's dragging up this kind of wobbly curve, and I will type 0.07. Like so. And then what I'll do is I'll select the two extruded surfaces, our road surface, and I'll click Join. Now you might want to start, and actually for your assignment one, I'd really please use nice layer organization. We do have all this Meerkat 2D information. We might want to start a 3D kind of parent layer. So I'm going to right click in my layers tab, click new layer, and I'll call this 3D geometry. And then under here, I'll right click my 3D geometry, I'll go to new sublayer, and I'll click street. Oh. I will rename this layer street. I will change this to the street layer, and maybe I'll change its color. Not necessary, but I like doing this. So there is our kind of very basic street. And for this site model, this is all you really need to do. I like dropping it a bit, and that is about that. What you're gonna do for things like sidewalks is you're literally gonna do the same thing, but you're gonna slice it. You don't have to worry about dropping it. So let's go back into top. We can essentially just offset the edge of this surface to get the proper layer. So what I'd do for, let's say, I'll do this sidewalk down here, is I will go to curve, offset curve. I'll select this surface edge. I will click D to offset a certain amount. About there. I'll make sure, yeah, that's about, you know, hitting all the sidewalks. For this example, I'm also ignoring this road. You know, for your own site models, you'll need to include the crossroads. You can see that the curve does not extend far enough here, so I'll go curve, extend curve by line. I'll extend this a little bit on both edges, and then I will offset this curve. So here I'll do a distance of 1 meter. Standard sidewalk width. You can see that it's more or less lining up over the ortho image. I'll select my surface and I will go split again. So I just click the little split icon right there. And now we have this surface. And that is working out quite nicely. So I'll make a new layer in my geometry layer, or in my 3D geometry layer. I'll make a new layer called sidewalks. I'll change that to this layer. And then I'll also create a new layer called grass, maybe. So new sublayer, I'll just call it grass. Lawn, park, whatever. And I will select all this other stuff right there. That probably isn't grass. Change that layer. I'll change it to a nice, beautiful fecund green. And there we have our grass. So the other thing you can do, and I do all the time when I'm sort of developing a site model like this, is Google Street View is your friend. So for example, you might be wondering, well, why is there this weird bump right there? That doesn't make much sense. If you know, drop your little yellow guy in Google Street View, you can see, oh, okay, cool. Like there's steps up to that sidewalk. So if you really wanted to, you know, it's reading week, you're like, I've already finished all my homework and it's only Tuesday, and you want to model some stairs, you know, maybe try calling some friends first. But if no one picks up, you can use Google Street View and sort of to model in some finer detail. Now, on a smaller site, this kind of stuff really does make a site model. So that's worth doing. And now, right now, these are all kind of like just solid colors in Rhino. It doesn't look very good, but in our next class, we'll sort of actually be texturing this, and you'll quickly see how this sort of comes to life and starts to look like a real impressive site model. So does anyone have any questions about how they would go about in this course making roads and paths and things like this? So it's pretty straightforward stuff. You can get into things like, I mean, if this looks kind of wobbly to you and you want to fix this, you can start to straighten out roads, but I wouldn't bother at this scale. So the next thing I want to do is, since our site is adjacent to some railroad tracks, I want to quickly just get in some grasshopper practice. So this is kind of like a hodgepodge of all these different techniques to make a site model. And I thought doing some railroad building would be a good way to review some things in Grasshopper. So essentially what we're going to do is we're going to open Grasshopper now. And also for anyone who was expecting a full-on Grasshopper course, I assure you that once we're through the site model, it'll be a lot more Grasshopper heavy. So we're just sort of establishing this base model first. So I am going to open my notes. You can just start with a blank document. We'll work through the entire thing. And I will open that as well. Okay. So this is an instance where we're going to use the Meerkat data a little bit more directly. So in your larger site model, when you import the railroad data from Meerkat, from the City of Vancouver site, you're going to see, depending on the extent of your site model, you're going to see all these kind of overlapping and intricate railways. And they'll come in just as lines. So our job here is to take these lines and convert them to something that's a little bit more railroad-ish. So what we're going to do is we're going to start by just referencing one of these lines. So in your Rhino file, it's going to be on the railways layer, and you can just select whichever one you want. So to select this curve, we're going to go to params, geometry, curve. We'll select our curve right here. We'll right-click this input component, and we'll go set one curve. Now we'll right-click this component and rename it something like railroad curve or whatnot, like so. Now we want to do a few things. So we want to divide this curve into perpendicular frames. So essentially what I mean by this is that we want to essentially take this curve and draw perpendicular lines across it in a regular interval. So if we have our curve right here, we want to essentially draw planes like this. And we'll use these planes for a lot of things. But of importance, we want to draw these planes before we project this line to 3 dimensions. And the reason why we want to do that is that if we have a 3-dimensional curve, so whereas that's 2D, this is now fully 3D, I assure you, we are going to, your planes are going to get all tilted, right? So they'll still be perpendicular in plan, but in elevation they might be twisted. And then in later steps, when we, let's say, try to use these planes to intersect the actual 3D curve above, you'll find that these intersections get all wacky. So that's my diagram of wacky. So we're going to just start by working with our 2D curve here. So we're going to go to curve, division, perpendicular frames. So generate a number of equally spaced perpendicular frames along a curve. And we will plug our railroad curve into the curve. Now you can see by default the count is 10. Since, I mean, we're not railroad engineers, it doesn't really matter how many ties you have on this. We just want to make something that looks visually good. So we'll just grab a slider to kind of increase this count. So we'll double click, we'll create a slider. We need whole numbers, so we'll say minimum 10, maximum, let's say 100. Click enter. We'll right click this slider, name it number of railroad ties. I think that's what the horizontal things are called. And we'll plug that into the count. And now you can see what's happening is in 3D, on our XY plane, we have all these kind of perpendicular planes going across the curve. So the next thing we want to do is we want to offset these. So if we think about how the ties are going to work, essentially we could draw lines based on these planes, you know, but it's probably easier to just kind of draw them from one offset curve to the other offset curve. So what we'll do, also I'm going to turn off this ortho image here because since it's not properly aligned, it's more distracting than anything. So I'm just going to delete it. What we're going to do is we're going to offset this curve. So we're going to go to Curve, Utilities, Offset Curve. And so offset a curve with a specified distance. Curve input, we're going to plug in our railroad curve. Distance is going to be our width of the tracks, but we'll sort of divide it by 2. So, and I'll show you what I mean. So if we very simply were to, you know, have a width of a track that was, you know, let's say 2, and we have a center line of that railroad, simply what we're going to do is we're going to offset 1. So 1. And then we're going to offset in the opposite direction, -1. So that's why width 2, offset 1, and -1. So that's what we're going to do there. So to do that, we're going to first start with a slider. So we'll double click. And railroad width could be 1.5 meters or whatever. So we'll go for some floating point numbers. So we'll start from, let's say, 0.25 for a little, I don't know, LRT rail. And then we'll do the less than symbol and go up to 4.00 meters. And we will right click this slider and we will call it railroad width. So essentially what we're going to do here, can anyone think of if I right click on distance and I were to go to expression, can anyone think of the expression I might put in here to divide this value by 2? Exactly. So remember, if we're going to use the expression editor, so what the expression editor does is it just modifies your input by a very simple expression. It always uses the variable x. So in this case, if we want to divide our width by 2, we can just put x divided by, so the little \2. So x divided by 2. And then we can plug our width into the distance input. So now you can see if we hover over our distance input, it says 0.125. So it's taking that input and it's dividing it by 2. We also have to offset our distance by -0.5, so -0.125 in this case. So what we're going to do is we'll go to math, operators, and then negative. So that's math, operators, negative. We'll plug our slider into the value input. You can see it's just going to simply give us negative 0.25. And then we're going to take that, we're going to hold shift, so we get the little green arrow and addition sign icon, and we're going to drag that into distance as well. So now I have two offset curves, and if we hover over distance, you can see it's 0.125 and negative 0.125, giving us a width of 0.25. And I'll just increase this to, I don't know, 1 point, maybe 2. Any railroad enthusiasts here? Tell me what the actual width is. You can look up these things. So for this, we just want to do what's, visually feels right. So now we have these offset curves. What we're going to do is we are going to intersect them with these planes to sort of draw the endpoints of our ties. So the ties, I'm assuming, are these things that go across the railroad. So to do that, we'll go to intersect. We'll go to mathematical. And then we will go to curve, plane. So intersect, mathematical, curve, plane. The curve is going to be our offset curves, and our frames are going to go into the plane. Now, considering that we want to draw straight lines to represent these ties, and considering that we have frames that represent the location of the ties, do we want to graft our frames before putting in plane, or do we want to graft our curves before putting in curve? It's 50-50. No. So the reason why we want to graft our frames is that if we were to graft our curve, essentially what this is going to do, well, let's see. We can actually kind of see what this does. So why don't we start out by grafting our curves? You can actually, if you look at this, if you hover over a curve, you can see that these things are in two lists. So our two lists are 0, 0, and 0, 1. So effectively they are grafted. So in this case, we should flatten them. But let's just try plugging curves into curve. So you can see they're already grafted because they have this dashed line. And now let's try plugging the frames into the plane and see what happens. What you see is that we have a bunch of points in their own list. So we have 74 points in this case, but they're all sort of by themselves, right? So if we were to try to draw a line between them, it just wouldn't work. So we'd go curve, spline, polyline. Nothing's going to happen, right? But if we, and again, this is a good thing to do if you have a ton of ties. I'm going to right click on my canvas, go to lock solver. So that means that it's not going to update. I'm going to right click on curve. I'm going to flatten it so that these curves now are just in one list. And then I'm going to right click on my planes and I'm going to go graft. So each frame is considered by itself. So what we're saying is each plane intersect with the two curves at once. And then I'm going to right click on my canvas. I'll click the lock solver component again. And now you can see that actually it's kind of the same thing, but I assure you it's right. So if we right click on points and go to simplify, what you're going to see is that the lists are organized in 0, 0, 0, 1. 1, 0, 1, 1, 2, 0, 2, 1. And what that means is that each plane is the first number in this list. So the 0 in the 0, 0 means the first plane. The 1 in the 1, 0 means the second plane. The 2 in the 2, 0 means that plane. And then the second number, 0, and then 1 equals the 2 curves. So we'll use a component a little bit further on, but this sort of puts in the right order. And that's just another example of how data kind of is represented in a data management way within Grasshopper itself. So again, just referring to my notes to see what I did. So what we're going to do here is we are going to draw a line through all these points. Okay. I don't know what I was doing there. That's okay. What we're going to do is we're going to take our offset curves, we're going to extrude them up, and we're going to intersect them with the surface. So these 2 points, or these 2 lines here, we're going to bring them up, and then we're going to intersect them. So we will go to surface, freeform, extrude. So surface, freeform, extrude. The base, so that's the curves we're going to extrude, are going to be our offset curves. And the direction is going to be straight up in a distance that intersects with this surface. So we're going to go to vector, vector, unit Z. So you can see we're starting to extrude right here. The factor, we want to make sure that these surfaces intersect with this surface. So what we're going to do is we're going to right click on the factor, go to set number, and click on, let's say 100. So that's 100 meters. You can see now they are indeed intersecting. And what we are going to do then is we are going to go to intersection. So intersection, physical this time because it's 2 physical Rhino objects. We're going to go to BREP, BREP. BREP A will be our extrusions. And BREP B is going to be this surface, which we haven't yet referenced, so let's do that now. So what we're going to do is we're going to select this surface. We're going to go to params, geometry, surface. So params, geometry, surface. I'll right click the surface component. I'll go set one surface. You can see it's green, so that means it's referenced. I'll right click this surface component. I'll just type ground. And I will plug this into BREP B. So now you see we have these 2 little curves here. And now at this point, I think it's worth kind of stepping back and cleaning up a little bit. So we have our extrusion, we have our ground, we have our unit Z. I'm just going to group these together. And this group, I'll right click on the group and I'll just call it track ground intersection. And then what we're going to do here is we are going to delete this polyline thing because I just remembered where I was going with that. And we're just going to call this right here. So our offset curve, our perp frames, and our curve / plane intersection. We'll group that and we'll call them tie points. So this is sort of the points which make up the ends of the ties. And what I'm going to do is I'm going to preview off my extrusion. I'll preview off all these planes because they're kind of distracting, create a little bit of a visual mess. I'll preview off that. So now what we have is we have our tie points and our 2 tracks here. So can anyone think of, just logically speaking, how you would go about getting these points directly onto this surface. So take these points that are projected on our C-plane and put them on this surface, straight up. How would you move them up the right amount? So think about you're making a physical model, and maybe that's not the best analogy. Maybe you have a laser pointer. I'm trying to think of a physical analogy. Essentially in Rhino space, we can just think of draw a straight line straight up from each of these points and figure out where it intersects with the surface. So that's kind of what we're going to do. So what we're going to do is we're going to draw a straight line from each of these points. So we will go to curve, primitive, line SDL. We will take our points, put them into the start input. And you can see by default, the line direction is 0, 0, 1, so straight up. And the length by default is 1. For the kind of intersection we're going to do, I don't think the length should matter, so we can just leave it like, actually, yeah, it does matter. So we'll switch our length to, let's say, 100 to make sure we get this intersection. And now we're going to go to intersection, mathematical, or intersection, physical, and then we're going to go to BREP curve, or actually surface curve. So intersection, physical, surface curve. Our surface is going to be our reference ground plane right here. So we'll take that reference ground plane, plug into the surface, and our curve will be these lines. So we'll plug these lines into the curve input. And now you can see we have our intersections. Now you'll note that some of them don't intersect. That's fine. We're going to sort of figure out how to clean that up just in the next step here. So I'm going to preview off my line SDL component. And now what we have is our two tracks and all our little tie endpoints.
Was line SDL a polygon?
No.
Oh, poly. It's just line.
Yeah, line SDL. So it's curve, primitive, line SDL, which stands for start direction length. So what we're going to do now, we have all our curves, or all our points rather. We're going to convert our tie ends to lines, and then after that we're going to sort of make them three-dimensional objects. So if you look at the points from the point intersections, you'll see that it has the same data format. So to get rid of any superfluous zero, I can right-click on points and go to simplify. Makes it a little bit easier to see. And you can see what happens is that we have 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. So if we want to view that, I just want to show you this. We're going to go to params, utilities, param viewer. And we'll plug our points into the param viewer, just so we can see what's going on here. So you can see data with 74 branches, 0, 0, 0, 1. Remember in this case, this 0, this first one is representing that original plane that made the intersection. The second 0 in each of these lists is representing either curve 0 or curve 1. So what we need to do to draw lines between these things is we essentially need to say, get rid of the second 0 and 1 and only count the first number in this path. So essentially 0, 0, 0, 1, if we get rid of the zeros and ones, then they're both 0, right? 1, 0, 1, 1, if we get rid of the second number in the path, aka the curve they're on, then we'll just end up with 1. So the component we can use to do this is called trim, and it's an extremely, extremely handy component. It's under set, tree, trim. So where is, I always just type trim. Trim tree. So set, tree, trim tree. And essentially if trim tree, hover over it, reduce the complexity of the tree by merging the outermost branches. So the gardening analogy continues. The tree input is the data tree to flatten, so that's going to be our points. And the depth is number of outermost branches to merge. So what that means when it says outermost branches, it means the sort of trailing number at the end of all these lists. So in this case, the outermost branch is the 0, 1, 0, 1, 0, 1 times 74. So we'll put our points into the tree. The depth by default is 1. That's what we want. And now what I'm going to do is I'm just going to copy and paste my param viewer. So Control C, Control V. I'm going to plug my tree output from the trim tree into there. And you can see data with 37 branches. It has gone rid of the last branch. And you can see that 0, 0 had no intersections. 0, 1 had one intersection. So 0 only has one item. Whereas 1, 0 has one item, 1, 1 has one item, so branch 1 has 2 items. And if we go down to the end, you can see there's another branch that only has one item, and that's because if we look at this here, there is only one intersection here. So that's what these lists represent, right? They represent these pairing of points. So to draw our tie lines across them, we can simply go to curve, primitive, and then actually we want to go to curve, spline, polyline. So curve, spline, polyline. And we want to take our tree output from our trim tree and plug into the vertices. And you can see that we have all our tie lines. You can see that this component's orange, insufficient points for a polyline. And it's giving us that warning because it's trying to draw a polyline from this one point. It can't do it, so it's giving us a warning. But again, red is kind of like, I guess it's like, you know, traffic lights. Like yellow means, hey, slow down. Red means stop, like something's wrong. But in this case, yellow is fine. So now what we have, why don't we group this stuff here? I'm going to move this all down so it's sort of just a little bit tidier looking. We're going to group all of these components like so. And I will call this tie lines. And for your own work, I want to encourage you to get into this habit. Again, not for assignment 1, but for assignment 2 and 3, you will be marked for your lack of or you know, hopefully abundance of paneled notes. So I'm going to go to param input panel. I'm just going to put a panel here in this group, and I'll say something like trimmed the outermost branch to couple the tie line points. And in assignment 2 and 3, this is the kind of note I'm looking for. Again, for assignment 1, you don't have to worry about this, but it's a good habit to get into. So now we have our polylines going across, and we also have our 2 tracks. So simply what we can do is we're just going to quickly draw rectangles, and we are going to sort of loft them. So to do this, we're going to use perpendicular planes again. So let's start on our rail lines again. We're going to go to curve. We're going to go to division and then perpendicular frames. We're going to plug these curves into our perpendicular frames, so you can see it's generating these perpendicular frames. Again, these frames, since they're on 3D curves now, they might twist. For something as flat as this, it doesn't really matter. If you're really intrigued on how to ensure that they're totally consistently flat, ask me, I can show you. But for right now, this looks good enough. And what we're going to do is we're going to draw rectangles on each of these planes and then loft them. So what we'll do is we will go to curve, primitive, rectangle. So curve, primitive, rectangle. So create a rectangle on a plane. We're going to plug the frames into the plane. I'm going to turn off the visibility for the perp frame, so right-click preview off so we can see our rectangles. So there are rather large rectangles. And then what we're going to do is we're going to define their X size and their Y size. So for our X size, we're going to have something that's similar to our offset, where the width equals, you know, if we want a width of 1, then we'd say -5 or -0.5 to 0.5. So what we'll do is we'll go to Math, Domain, Construct Domain, plug that into X size, and then we'll create a slider. So I'm going to double click on my canvas. I will go from 0.05 to 1.00, click enter. And essentially what I want to do is I want to use an expression for both my domain start and domain end. So again, remember, if we have a width of, let's just simply say 1, our domain start needs to be -0.5, our domain end needs to be 0.5. So what I can do is I can right click on domain start, I can go to expression, and then can anyone think of what expression I'd put to get -0.5 from 1? Divide, you forgot the word divided in there. So it's -x divided by 2. So that just multiplies x by -1 and divides it by 2. So if we plug our number slider in here, you'll see that our domain started as -0.5. Our domain end, if we right click on this and go to expression, in this one now we're all old pros at this, so can someone confidently say what the expression will be? Exactly, x divided by 2. So we'll commit changes and we'll plug the number slider in there. And now you can see what happens is we are increasing what I thought was our x value, but is actually our y. No problem. If your planes act like this, you can simply take your domain and put it into y. So sometimes planes aren't oriented the way you thought. And I just disconnected x there. Yours might be the inverse of mine. So x might actually be the width. But for us, we just want to have this first slider controlling the width. So now you can see, since I put domain into y size instead of x size, now it's controlling the width. So that looks about a good rail width. And then for the x size, or AKA the height of the rail, what we'll do is we will simply, instead of going negative something to a value, we're going to go 0 to a value, because we always want this rail to be above the ground. And simply what we can do is we can plug a slider into this x size, and we'll know that it will give us the right 0 to a domain. So I'll double click here. I'll make another slider. I'll go 0.01 less than, we'll say 1.00 is the max. And I'll plug that into x size. And now you can see that's a slider that controls the height. But then it's also going in the opposite way, which is kind of lame. So can anyone think of how we can make sure that our curves go up the correct way? Because right now they're sort of doing what they want. So there's a bunch of ways to do it. The way I might do it is I might actually just make 2 of these extrusions, and then what I would do is I would select the one that's highest. So what we can do here is we can go to Math, Operators, Negative, plug our slider into the negative component, hold Shift, plug into X size, and then what we are going to want to do is we are going to want to graphed this, which, yeah, that's gonna work. Yeah, okay. It's kind of a weird reason why this works in this case, and the reason why this is working is what's happening is if we look at our curves, essentially what's going on is one curve is flipped. And essentially what this means is that this curve is considering its up direction down, and this one's considering its up direction up. So what's happening here is that if we right-click simplify on plane to get rid of all the superfluous zeros, if we right-click simplify on our x size, you can see that we also have 0 and 1. So 0 and 1 in plane, 0 and 1 in x size. What this means is that that the 1 value is affecting one curve and the -1 value is affecting the other curve. So then that way, even though these curves are flipped, they're both going in the proper order, or at least the same order now, because we're going -1 and 1. What I'm going to do now is I'm simply just going to, I guess, right-click the x size. No, I won't. I'm going to plug the negative curve in first, and then I'm going to plug in the positive curve like so. So that's maybe, there's a bunch of ways of doing this. Grasshopper, you'll find that there's kind of lots of troubleshooting that you can do. A lot of the times you just need to find a way that works. What I'm going to do here, since that was sort of a on the fly fix, is I'm going to save this in the Dropbox for everyone, just so we all have this. Again, this first part of the course isn't so much about Grasshopper, so let's put it in here. Yeah, okay, so I'll go through that again. So you all sort of get what I mean when I'm putting two x sizes into here, and when I graphed, if you hover over x size, what you see is that you have one x size which is in the 0 branch and one x size which is in the 1 branch, right? Let's say, for sake of conversation, in this case, the 0 branch is the positive value and the negative value is the 1 branch. What we also have is, if you look at our planes, we have 2 branches that both contain 11 planes. So those are essentially the planes on each curve. In this case, since our curve is, one of these curves is facing up and one of them is facing down, like that, essentially what we're doing here is we're saying, hey, match positive value, which is in the 0 list, to the curve that is in the 0 list. Match the negative value, which is in the 1 list, to the curve, which is in the 1 list. So if your curves are, let's just disconnect everything from this x size thing, so disconnect all. If your curves are, let's say, going the wrong way, so I'm going to plug in my positive slider first, and then I'll hold shift and plug in my negative slider. What this means is that the positive slider is going to the curve that's facing down, and the negative slider is going to the curve that's facing up. So if you want to reverse that, if your case is the opposite, we can just disconnect everything from the x size, disconnect all, and we plug in the negative slider first, or the negative value first. So that means the negative value is going to the curve that's facing down. Hold shift and plug in our positive value second, which means our positive value is going to the curve that's facing up. So that's kind of, sometimes things in Grasshopper maybe don't work out exactly how you want them to. When I was going through this in preparation, both my curves were the same direction. And if that's the case where both of your curves are the same direction, you can simply right-click on X size and disconnect your negative result, and that'll apply a positive result to both your curves. So you just need to kind of choose which direction you need there. So after we have these rectangles, you can see we have 11 rectangles in 2 paths. So each path is corresponding to a curve. So now we can go to surface, freeform, sweep 1. So so there's a few things in sweep 1. The first input is rail curve. So we're gonna simply go to our curves from our BREP intersection. We will right-click on our rail input and go simplified just to get rid of all the superfluous zeros at the beginning. So now we have 2 paths, 0 and 1. Our sections, which are our rectangles, you can see they're also in list with the numbers 0 and 1. We'll plug that into our sections. And now you can see we get our rails like so. So what I'm going to do now, since we've gone through all of this, I'm just going to preview off all of this stuff here. And I'm going to group all of these components here, and I will call it building the rails. And for all of your future reference, I'm going to make a little note. For some reason, if you ever want to, you can always create a new sketch in Grasshopper. So I'll draw a little arrow to make it very apparent to everyone. Click. And I'll just say, refer to the class recording. You might need negative values for your rectangles, positive values, or positive and negative.
Is there even why you would recommend doing it like this? Because I noticed that I could also go into the number slider and then just do the expression and then minus X. And then also put, is there like a right or wrong?
No, there's not a right or wrong. It's whatever works for you. I like doing it this way because it ensures that both rails are the same height. Whereas with a number slider, you might accidentally switch one to 0.25 and then 0.4.
No, I mean like the number slider that you have there.
Yeah.
I just went into expressions and did negative X. Then I put it up to the top.
Yeah, if that works for you, it works for you.
Will that affect it like later on? Or
It might if your curves are different. So I'd just keep an eye out for that. So you don't want to be responsible for derailing a train. And so anyways, we have these 2 rails. And now what we're going to do is we're going to simply make all our tie lines. So again, we're going to do the kind of a similar thing. We're just going to draw rectangles across them. So we are going to go to curve, division, perpendicular frames. The count for this, since we just want to draw rectangles on the end of these curves, we'll just set the count to be 1. So that means that there's just 1 section per curve, which means that there's just 1 plane on each end. And we are going to draw another rectangle. So we'll go to curve, primitive, rectangle. And for these, simply what we're going to do is we're just going to assume these are square. I feel that if you want to make them, rectangular instead, you can change your X size and Y size. But what I'm going to do is I'm going to double click to make a slider. So I'm going to make my minimum value 0.01 and then go less than 1.00. Enter. And then what I'll do is I'll just call this tie width. And then I am going to go to math operators negative. I will plug my negative or my slider into my negative input. And then I'm just going to go to domain construct domain, and I'm just going to plug my slider into domain start and my negative result into domain end. We could have avoided using this negative component. It's just another way of doing it. We're going to enter two expressions into our domain start and domain end. Both will be x divided by 2 because we have this negative component there. So I'm right-clicking on domain start, going to expression, x divided by 2, commit changes. I am going to right-click on my domain end. I'm going to go to expression, x divided by 2. And now I will just plug this domain into my x size and my y size. I'll preview off these frames. And then what you can see is we have these little rectangles, or I guess squares, showing up on the end of our curves. And then what we can do is we can simply go to Surface, Freeform, Loft, plug the rectangles into the curves. You see we have our ties like so. And then we will go to Surface, Utilities, Cap Holes. And these will just sort of cap our holes. So that's kind of a way of making a railroad. So what I'll do is I'll just group these things here. And I'll call these railroad ties. I mean, there's other things you could do if you want. If you're really feeling keen, you might want to extend the ties using the curve, extend curve component. You might want to offset your actual rail so it's sitting above the ties. In that case, we can actually quickly do that one. You would just go to Transform, Euclidean Move. You would go to Vector, Vector, Unit Z. You'd plug Unit Z into your motion. You'd plug your tie width into your factor. You would right-click on factor, go to expression, x divided by 2, because we want to just move it up half the width. And then our swept rail on the edge here, we just plug that into the move. So now it's moved up by the height of the ties. So now the rails are kind of sitting on top of the ties if you want to do that. Essentially, you just want to go for something that looks good when in a axonometric view like this, and also knowing that in the future, your bridge is going to sort of go from this point to this point, so you might want to have some close-up. So it's worth making your ties and railroads look, you know, somewhat believable. So I'm going to save this in the Dropbox so you can all use this. Please refer back to the video if there's anything you need to understand about it or ask me a question. But does anyone have any questions right now about this? Okay, so I think what I am going to do, since we have 40 minutes left, there were a few other things that I wanted to show you, and I will I'm gonna just take a couple minutes to do that because they're very easy things. And then that will sort of give you the skill set in addition to the video on YouTube to essentially move forward with your project. So we won't worry about capping edges. I'll do that next class. The one final thing I want to do is talk about just importing assets or kind of cars, train cars, et cetera, into your site model, because personally I feel they add a lot. So what you can do is if you go to the Dropbox folder under class files, you're going to see there's a folder called assets. And I can quickly go through this. You don't have to follow along. But what you can do is you can just find an OBJ, you'll find a few OBJ files in here. And what you can do with OBJ files in particular is you can open them in Rhino and use all their textures. So for example, under the, let's just go for Boxcar here, you'll see that there's all these files. What you're going to do is you're just going to right click on the .obj file. So Windows says it's a 3D object. And you are going to open it in Rhino. And there's a few import options I want to go through. It's pretty straightforward. So import OBJ groups as, you probably just want to import them as groups, and that's so that you don't, essentially explode your model into a lot of different pieces. A lot of the times I'll say ignore textures. In this case, if you find something that has a nice texture on it, make sure that it's not ignored. And then after that, you can just click OK. And you can see that there we have our nice boxcar. If we look at our rendered view, so view, rendered, you can see that this is owned by Ochre Incorporated, but it has kind of these nice textures on it. So what I'm going to do though, and I'd encourage you all to do this, is I'd create blocks out of these. And the reason why you want to create a block is if you edit one, you're going to edit all of it. Also, when you first open the file, you probably want to change its group just so you don't end up with a million, or change its layer, just so you don't end up with a million layers when you copy it into Rhino. So for example, I'd just select all this geometry. I'd make a new layer called Boxcar. I'd right click on Boxcar, change object layer. And then once I've done that, I'd have everything selected and I'd type block. And then the block base point, you can just click somewhere, towards the center. And then this block, you're gonna call it Boxcar. And if you're not familiar with what a block is, it sort of came from AutoCAD parlance. Essentially what it allows you to do is to edit one item and it'll apply those effects to all the other ones. And you do that in Rhino by just, it'll say one block instance add to selection. You can either type block edit or you can just double click on it. This little window will come up telling you you're in block edit. And for instance, let's say we have this underside of our rail car. We're finding that it looks too dull. We could go and we could just change its material. So for example, we could change it to default material. Now it has this nice, bright, pristine underside. It's a new boxcar. We'd click OK. And now you can see that it makes that changes to all the boxcars. Furthermore, you can always add geometry. So let's say that our boxcars have a little box underneath. You could select said box, go add object, click, select that. Oh, I guess since I made it in the box, it's already added. So if you make an object in a block, I guess it's already in the block. So when you save, it will add to all your blocks. Another thing you want to do before importing into your Rhino file is to figure out how big this thing is. And you can quickly do that by just selecting, well, you don't even have to select your item. You can just go to Analyze Distance. So this is, I guess it looks like it is about 1.192 meters. I'm not a boxcar expert, but that seems kind of small. But it doesn't seem super, super small. So what I'll do is just make sure that it's not like 10 millimeters or whatever. But once you're happy with your object, just Control-C. And so copy it to your clipboard and then bring it into your file. Control-V. And there's our, actually, it is a tiny, tiny little boxcar. So what you can do, and what I do a lot of the times, is I'll just, like on Google, I'll type in like box car size. Usually it's a car model. So the most common box cars are 50 feet long, right? So Then we can just go into Rhino, select this boxcar, go to Transform Scale 3D. I'm doing this very roughly, but then I just type 50 feet. So there's our boxcar, and then now what you can do is you can just position it on, in this case, our track. So in your site model, I do want to see like some assets. Again, it's just kind of a fun thing, and I think it will end up making your final drawings look real sharp. Again, these will already be pre-textured a lot of the case. You can add your own textures. We'll sort of quickly go over adding textures next class. But essentially, for the sake of these renders, as long as it looks good in the view, that's good enough. So from an axonometric, who cares if the wheels of this boxcar is intersecting with the rail? It'll look good in a rendered view. So there it is. In Enscape, it'll look very good. The one thing I want to also leave you with is that what I'll look for if I'm looking for a car, just look up car free 3D OBJ. Something like that. There's CG Traders and free3d.com. Not responsible. These sites are good, just like don't download from like, you know, like freecarwares.ru or anything. Like I'm not responsible for anything you download. But there are lots of 3D models there. Just make sure it's the .obj format. .fbx and .blend will not work. So with all that, I know we've sort of covered a lot, and there's more in the video. The video is kind of a little bit more straightforward. Like I said, it's mostly importing stuff from Meerkat. You have a bit of stuff to work through. We have about half an hour left for questions and work time. Depending on how, I guess, what kind of progress we make, I'll probably take out a little bit of stuff from next class just so we all have time to sort of finish this site model to a high level. But before you guys start working, do you have any questions? Okay. Does it feel like there's a lot of stuff, or does it feel straightforward? Lots of straightforward stuff? Yeah. I know it feels kind of like I said, a bit of a hodgepodge, but ultimately when you're making a site model or doing most things, you can't rely on one method for everything. So again, I'll be up here to answer your questions. Zara is also around to answer your questions, and we have about half an hour to work, so let's get to it.